Welcome to Code Report. I'm your host, Connor Hoekstra. Before we jump into things, let's take a look at some comments that people posted on my video from a LeetCode problem, find eventual safe states. So Dennis had pointed out that the time complexity of the problem actually isn't linear, it's quadratic, and he pointed out that you could pass your unordered set by reference and then just pop off or erase your nodes by saving it after you come out of each recursion call. And Ma also pointed out the same thing but provided a different solution. So let's take a look at what that code would look like.
So here is the original code for our problem, find eventual safe states, and you can see that we're passing by value our unordered set of integers, visited nodes, which was intentional but results in a time complexity that's not linear. It'll be quadratic. So Dennis's recommendation was to save an iterator pointing to our node that we just inserted, and we can do that by doing a dot first and then saving this. So anytime we insert into an unordered set, it returns to us a pair, and the first of that pair is an iterator pointing to the location where we inserted our element. So in order for this to work, all we have to do is move our visited nodes outside the loop, move our cycle nodes insert up into this loop, and then afterwards we can just do a visited nodes dot erase of this iterator, and this will result in linear runtime. And moving back to our original solution that was quadratic, Ma's recommendation was something similar, but a little less changes. So once again, pass by reference, move our visited nodes outside the loop, and our cycle nodes insert inside this loop. And then all we have to do is do a dot clear on our visited nodes for each iteration. And this will also result in linear runtime.
So thank you to Dennis and Ma for posting those comments. Let's take a look at the contest that happened last week.
Taking a look at the contest that happened last week, originally we only had two contests announced, Educational 40 from Codeforces on Thursday and the weekly LeetCode contest on Saturday night, but in between the last week we had Codeforces announce two more contests, so round 471 and round 472, which took place on Friday and Saturday. Taking a look at the top 10 leaderboards, we had Yui taking the top spot in both Codeforces round 471 and LeetCode contest 77. And in the Codeforces round 472, we had quite a few top-ranked individuals placing high. So the formerly ranked number 2 Umnik took the top spot. Another top 10 rated individual, Raid Whoosh, finishing in second as well. And something that I'm going to start doing going forward is reviewing the overall rankings for any sites that had contests over the past week. So those were LeetCode and Codeforces. So unsurprisingly, Yui still has the top spot for LeetCode. And we did have a little bit of movement in Codeforces. Petra was formerly ranked number 1 last week, but Umnik has now taken that number 1 spot. I don't think Petra has been actively competing in too many of these contests, so it's mostly people moving around him. And still, the formerly ranked number 1 Tourist is still in 4th place. The problems that we'll be covering in today's video are going to be problem 1 and 2 from LeetCode contest 77, and later this week I'll be covering problem 4 from the same contest, contest 77, as well as all 3 problems from the upcoming Top Coder SRM 732 on Thursday. So let's take a look at our first problem. Our first problem that we'll be covering today is problem 1 from LeetCode contest 77, entitled Number of Lines to Write String. The problem states we are to write the letters of a given string S from left to right into lines. Each line has a maximum width of 100 units, and if writing a letter would cause the width of the line to exceed 100 units, it is written on the next line. We are given an array widths, and array where widths 0 is the width of A, widths 1 is the width of B, and widths 25 is the width of Z. Now answer 2 questions. How many lines have at least 1 character from S, and what is the width used by the last such line? Return your answer as an integer list of length 2. And note that the length of S will be at most 1000. S will contain only lowercase letters, and width is going to be an array of length 26, and those widths are going to be between the range 2 and 10. So let's take a look at an example that LeetCode gave us. So here we have basically our array width, which is saying that each of our characters from A to Z are all going to have width 10, and then our string S, which we have to construct on a certain number of lines. And each line is going to have at most 100 columns. And so if we construct these lines, it's going to look as follows. So we're going to end up with 10 characters at most on each line. So our first line will have A to J, our second line will have K to T, and then on our last line we'll have the last 6 letters of our string. And so the output for this example is going to be 360, which means 3 lines, and on our last line we have 60 columns being used. And so this is going to be a pretty straightforward problem. All we're going to do is keep track of 2 integers, lines, which is the number of lines we have, and column, which is going to keep track of our current column. And we're just going to add, we're going to loop through our string, and for each character look up its width and add that to our current column. And anytime this exceeds 100, we are going to have to increment our lines and then reset our column to be equal to the current width of the character that exceeded 100. So the only sort of tricky part of this problem is that if we don't have a line that's filling out to the 100th column, so for instance, if we change the width of J and T to be 5 and 8, we'll see something like this, where we have a little bit of unused space at the end of each line. And so we just have to be careful that we're not storing half of a character at the end of this line and then the other half at the beginning. And we're going to do that by anytime we exceed 100, resetting our column to be equal to the current width of our current character. So let's take a look at the code for this. So here we have our function number of lines, which takes 2 parameters, a vector of integer widths, which are the widths of our characters in our alphabet, and our string S, which we need to put on the lines. So we are going to start by declaring 2 integers, lines, our number of lines, and I to keep track of our column, and then we're going to loop through every character in S, look up the width of our current character, which we're going to do by subtracting the character A from our current character, and this will return the integer 0 to 25 based on which character. Then we pass that to our vector of integers widths, and that will give us the retrieve us the width of our current character. So we do a plus equals to our column, and at any point if our column exceeds 100, we do a post increment on lines, and then we reset our column to be equal to the current width of our current character. And once we complete this for loop, all we have to do is return lines plus 1, the plus 1 to take care of our current line that hasn't exceeded 100 and the number of columns on that last line. And we can just return this initializer list, which is going to construct a vector of integers. And the time complexity of this problem is going to be linear in the length of our string S. The second problem we'll be covering is problem 2 from LeetCode Contest 77, entitled Unique Morse Code Words. The problem states, International Morse Code defines a standard encoding where each letter is mapped to a series of dots and dashes as follows. A maps to dot dash, B maps to dash dot dot dot, C maps to dash dot dash dot, and so on. For convenience, the full table for the 26 letters of the English alphabet is given below. Now, given a list of words, each word can be written as a concatenation of the Morse code of each letter. For example, cab can be written as dash dot dash dot dash 4 dots and a dash. We'll call such a concatenation the transformation of a word. And the question asks us to return the number of different or unique transformations among all words we have. And note that the length of our array words will be at most 100, and the length of each word will be between 1 and 12 characters, and our words are only going to consist of lowercase letters. So let's take a look at the example that LeetCode gave us. So here we're given 4 words, gin, zen, gig, and MSG. And the output for this problem is going to be that there are 2 unique transformations. So the explanation shows that we have the transformation for each of our 4 words, and we'll notice that for gin and zen we have the same transformation, and for gig and MSG we also have the same transformation. So this problem is just going to consist of creating the transformation for each word and then inserting that word into either an unordered set or a set. And the reason for this is that if you know about about either of these data structures, they don't contain duplicates. So anytime you insert an item, it's going to check first if that item already exists. If it does, it won't do anything, and if it doesn't, then it'll add it to the set. And the only difference between unordered set and set is that unordered doesn't store them in sorted order, where set does store them in sorted order. So set is a little bit less efficient with log n operations, whereas unordered set has constant time operations in the average case. And so because we don't care about the order in which our transformations are stored, we're going to opt for using the unordered set. So let's take a look at our code. So here we have a function, unique Morse representations, that takes as a parameter a vector of string words. And we're going to start off by just declaring a vector of strings, and we're going to copy and paste all the Morse code transformations for each character into an initializer list and use that to construct our vector of strings, A for alphabet. And then we are going to construct an unordered set string and call this U. And then we're going to loop through using a range-based for loops. For each word and words, we're going to declare a string T for transformation. And then we'll have another range-based for loop where we loop through each of the characters in our word. And then we do a plus equals to our string T by getting the transformed character, which is a string from our vector of strings A. And we're going to use the same trick that we used in the previous problem by just subtracting the character A, which will give us an integer 0 to 25, and doing a lookup from our vector. And once we finish this inner range-based for loop, we have our completed transformed string T, and we can insert this into our unordered set, which, as I said before, won't insert duplicates. And once we've finished both of these nested loops, we can come out and just return the size of our unordered set. And the time complexity of this problem is going to be linear in the length of our total words. Taking a look at the contests that are happening next week, we have Topcoder SRM 732 happening on Thursday evening. We have the Google Code Jam practice round. So for those of you that don't know, Google hosts an annual competitive programming competition with a $15,000 first place prize. And you can register for that up until April 8th or 7th, I believe, which is when the qualification round starts. And a week before that, which is starting this Friday, they have a practice round where you can familiarize yourself with the environment. On Saturday, we have, of course, the weekly LeetCode contest in the evening, and in the morning, I'm going to be checking out the CodeChef lunchtime contest, and I'll be thinking about adding CodeChef to the list of sites that I cover. And we're finishing off the week with Codeforce's April Fool's contest. And of course, taking a look at the top 10 viewing countries, we didn't have much movement this week with the 9 countries at the top staying the same, but we did have a new 10th place country, which is Italy. So once again, and as always, thank you to everyone all around the world for watching.
As always, if you enjoyed this video, hit that like button. Make sure to follow me on Twitter for reminders 30 minutes before contests start. You can find all of the code that I use in my videos on my GitHub page. All of the links are in the description down below. And finally, if you want to make sure you don't miss any of my upcoming videos, make sure to hit that subscribe button. Thanks for watching, and I'll see you in the next video.